Okay, welcome to this lecture on C# network programming. I want to talk about multi-homed, multi-threaded client-server applications. In the previous lecture, I discussed multi-threading in the context of a client-server application, where we took the Echo server and turned it into a multi-threaded Echo server using a thread class from the threading namespace. This lecture comes from Chapter 19 of my book, C# for Artists, second edition, and we're going to jump ahead to page 565. The section is entitled Listening on Multiple IP Addresses. Okay, another word for this is multi-homed. So in the previous two Echo server examples, we listened on IP address 127.0.0.1. And that's good if you're not connected to a network and you're just doing local testing. But for all practical purposes, you really need to listen on a valid IP address. And if you're on a home network, then your computers probably have IP addresses assigned to them from the DNS or from your router. Okay, and you can do some realistic testing in that environment. Same as in a classroom or whatever. As long as you know the IP address of your server, then you can take a client and reach that server. Okay, so it turns out to make this happen, in other words, listening on multiple IP addresses simultaneously is actually very easy. And we really only have to make one change to the code. But I went ahead and made a few more changes, or at least I'm going to show you how to gather more statistics, because it'd be nice to list all the different IP addresses that are actually assigned to your machine. Okay, we know that they all machines have a local loopback adapter or local host called 127, or with the IP address 127.0.0.1. But I've modified the server or, the Echo server class to actually contain another method to show us some all the different IP addresses. So let's go ahead and take a look at the code. Okay, so this is the multi-IP, multi-threaded Echo server. Okay, so the code for the process client requests, which was introduced in the last example for the multi-threaded server, that doesn't really change. Okay, and the main method has a small change, and I'll show you what we do there. But the big change is this new method that I've introduced called show network configuration. Okay. Now, if we go up to the using statements, I'm using system.drawing. I'm wondering where I see. I'm setting the color for the foreground color, so that's console color.white. That's where the system.drawing comes in, I believe. System.io, system.net, system.net sockets. I don't think I really ever use that. System.net network information, we certainly will use that. And because we have to have this network interface class, we're going to create an array of those. And then, of course, we have using system.threading. So let's go through the main, and then we'll come back up to the show network config method. Okay, so our main method pretty much proceeds as the last example did. So we have TCPListener. We create a new TCPListener, set it to null. Then we have a try catch block. And then I call the show network config method as my first thing that I do when I enter the try block. And then I create my listener. I say listener equals new TCPListener. And instead of naming a particular IP address, I use IPAddress.Any. And that's the trick right there to make it a multi-homed server. is you just use IPAddress.Any. IP address is a class defined by the IP or the .NET framework. Okay, I'm listening on the same port. Really, you could program all this stuff to make it configurable, right? Here, I've just got it embedded into this code as an example. But at least now we have more flexibility on which IP address we can hit. We can hit localhost if we want. We can hit any other IP address assigned to this machine. And then I start the server and I say multi-IP echo server started. And then the rest is the same. So, I have a while block that just repeats forever. I listen for incoming client connections using listener.accept TCP client. And as soon as a client connection comes in, the method unblocks and returns a TCP client object. I print a message to the console saying accepted new client connection. And then I create a new thread. And the thread, I give it the name of the method process client request. And that method has remained unchanged since the last example. But I'll go through it here in a second. And then I do t.start for, to start the thread, passing in the TCP client reference to the TCP client object. This is called a parameterized thread start, just to review from the previous lecture. And then, but before I go into the process client request method again, just as a review, let me go through the show network config method. Okay. So when I first enter the try block of my server main method, I'm calling show network config. The first thing I do is I set the foreground color of the console to yellow so I can print yellow text. And then I use a class called network interface to create me an array that I'm calling adapters, okay? And then I call network interface. It has a static method called get all network interfaces. And that returns an array of network adapters, or network interfaces, I should say. And then I just use a for each statement to iterate through the list of interface adapters. So network interface adapter in adapters, console write line adapter.description, and then I write line with a tab /t adapter name, okay? And then I append the adapter.name. And then on the next line, I write a tab over with the MAC address, and then I append the physical address. And then I have another new class I'm using from the network information system.net.network information namespace called IP interface properties. And then I create this. It's a collection more than likely equals adapter.getIP properties. Okay, so I'm getting the properties from the adapter that I'm iterating over. And then I have another class called unicast IP address information collection, and I use the IP properties, which I just got up here on line 51, and I say IP properties.unicast addresses, and it gives me a collection of addresses. Then I step through each address of the unicast address information collection, saying unicast IP address information address in addresses, console.writeline /t IP address. And so I'm going to get the name of the adapter name, the physical address name, or the IP address. I'm sorry, the MAC address. And then I'm going to get all the IP addresses assigned to that MAC address. Okay. And then finally, when I create my thread and I pass in the client to my t.start or thread start method, then I'm calling the process client request method. My incoming object is an object, but I know it's a TCP client object type. So I'm going to cast the object argument parameter into a TCP client, and I'm going to assign it to my client reference. I'm going to create my stream reader, stream writer, Then I'm going to declare an empty string. And then I have a while loop, which just says, hey, you know, as long as the incoming string doesn't equal exit or null, write that information to the local console, and then using the writer, write it back out to the client. And then before that actually happens, I got to call writer.flush. And this code has not changed from the previous example. So the only code that changes is the addition of the show server network config and adding IPAddress.Any down here when I create my listener in my main method. And then, sorry to jump around, but back up to the show server network config method on line 57. The last thing I do before I exit is set the console color back to white. And then so all the config information is shown as yellow text, and the normal server information is shown as white, excuse me. Okay, so now what I've done is I did make a change to the Echo client in this particular case, and I added the capability to actually enter in a particular IP address from the console. If you don't enter in, you can still call it the old-fashioned way. If you just double-click the client executable, then it'll assume that you're trying to connect to 127.0.0.1. And if you're testing on the local machine, that will work. So up here on line 17, I create me an IP address, and I assign it IP address 127.0.0.1. And then I create me a port, or I declare a port, which is an integer. And then I try to process the arguments from the command line console. And if they're not, if that string is not null, or if the length is greater than 1, then I'm going to parse that IP address and assign it to the IP address variable, or, local variable. And then I'm going to proceed to connect to that IP address. And of course, if I can't connect, I'm going to throw an exception. Okay. So print out a message when I enter my try block saying attempting to connect to server at IP address whatever to port whatever. Okay. And then I'm going to convert my IP address to a string, and my port. My port is set at 8080. I did not give the capability of changing the port. Okay. So we're still going to try to connect to port 8080 by default. However, you could easily change the code to take a port as an argument as well and try connecting to that port. Then I create my TCP client, like I just said, okay? And then console.writeLine, if everything goes well, connection successful, and then I'm going to go ahead and proceed as usual, where I get my stream, create my stream reader and my stream writer, and from there on, the code is the same as it was in the previous example. So let's go ahead and see this code run. Let me open up the code, that folder. Okay. And let me change to that directory so I can compile it. Okay, and let's run it. Start. Multi-IP echo server. And then what you'll see is when the new window pops up, you'll see some yellow text. That's the result of calling my show network config method. And let's just go through that here real fast. So it shows I've got, I'm running a VM on a Mac. Okay, so this window, this development environment that looks like Windows, in the video that you're watching, it's actually a VM running in parallels on a big old Mac server. Okay, so, but it shows I have an Intel R1000 MT network connection. Adapter name is local area network. MAC address is listed, and then I have IP address v6 and an IP address v4, and then it shows me the IP address as a regular octet. So 10.211.55.6. Okay. And then I've got a software loopback interface 1, and it's assigned 127.0.0.1. And then I've got a Microsoft ISA-TAP adapter, and it's got a IP address assigned there, 10.21.55.6. Okay. Yeah, same as the one up here, 10.21.55.6. And then I have Teramo tunneling pseudo interface. Okay, so these are all the adapters that are assigned to the machine. Okay, really the only IP address that counts is 10.21.55.6. Okay, and your machine will have different, so I've got two. I got localhost or local loopback interface, 127.0.0.1 and 10.21.55.6. Okay. So now let's crank up the client machine, and let's change to that directory. And compile. Okay, so when I start this now, I should be able to connect to 10.211.55.6. So start echo client 10.211.55.6. Okay, so when I hit return, I should power up. Okay. So it says, you'll see the printout there, attempting to connect a server at 10.21.55.6. I should have got a connection, and I did. Okay, so I can power up another one with the same IP, or I can connect to 127, or I can just connect to the default, right? That would be 127.0.0.1. So if I hit return, boom. Okay, so I get that one. There's my other client. I can minimize this. And sure enough, I got a server printout that says, yes, another client connection came in. And then I can proceed as normal. So I can say, hello, client number 1. And I make that successful. And then I'll come up here. Hello from client number 2. Yes, and that works as well. Okay. So to review, to make your server multi-homed, which means listening on multiple IP addresses when you create your listener. Okay, let's go back to the code. When you start your listener, or when you create your listener, you want to use IPAddress.Any. IP address is a class in your .NET framework. Okay, it's got a .parse method. It's got some other methods. You want to look that IP address class up in the .NET documentation. But if you use IPAddress.Any, that tells your server to listen on any IP address that's assigned to that machine. And then all this networking config stuff was just code I wrote to show you all the different network interface adapters that are assigned to that machine. Okay. And then for your Echo client, you can write code to, take arguments from the command line. Or if you have a graphical user interface for your client, you can have text boxes where you can enter in the IP address and the port and then try to connect. Okay. So those are some ideas you can use to write a client to connect to a server. Okay. So let's take a look at what's coming down the pike for the next lecture. All right, so we covered the IPAddress.Any and walked through the network config. The next thing I want to talk about in the next video is how to send objects between client and the server. So right now we're sending an object. We're sending a string. Okay, string is serializable. So in order to send a custom object, like a user-defined data type, you're going to want to make sure that that data type is serializable. So if you haven't read up on serializable interface, then you want to read that in Chapter 17, I think it is, which is I/O. Okay. And I'll have another lecture on serializing objects. You can use serialization to save objects to disk or send them across a network. So anyway, thanks for listening to this lecture. Again, if you have any questions, you know how to email me, and look forward to answering any questions you may have. Okay, thank you very much.